Welcome you all to SST College Arts and Commerce, and this is SST College Edupedia. Myself Archana Nair. I am giving you a lecture about bisection method, which is then coming under the numerical methods of the syllabus of FYIT, and this is a method of this is a method of finding the roots of any transtential or polynomial equations. So finding the root of a quadratic equation is very easy, but to find the equation of a polynomial having higher side of degree is very difficult. So here we will find what is bisection method. By the name itself, bisection method is a method which will be bisecting two individual intervals, where the one individual interval is giving the function result as positive and the other one's function's result will be negative. Okay, so we can find what will be the result of, or how to find the bisection methods, initial intervals, and how can we calculate the different iterations. Iterations means it is the process of continuous calculation for the same equation with the in multiple values. That means in the previous iteration or in the initial iteration you will get a new x value, so that you have to substitute into the next f of x function equation, and again the new value have to be substituted into the next level of iteration. So this process keep on going until we get an accurate value or an approximate root for the given function. The bisection method evaluate the given polynomial to 0. That means we can say the given function can always be equal to 0. That is what we have to consider for the initial step. So here we are discussing what are the procedure to find the bisection method. So initially what we have to do, the given polynomial or any function given has to be calculated considered equal to 0. Then next is we have to find two real numbers as such a and b, that is the product of this a and b into the function should be less than 0. That means if one of the function attached with a or b should be negative, so that the result of f of a and f of b will give you a negative result, so that will be equal to less than 0. Then to find the approximation, what we have to do, the approximation of the approximation is also considered as the bisection. Bisection means we have find the two intervals called as a and b. This a and b will be the initial two intervals. So to find the approximate root of the initial value, so we have to consider the median or the average of these two values a and b. This a and b will be the half of the sum of a and b will be equal to the xn, and that we can find as the initial approximation. So for the initial approximation we have few conditions. That means if the f of a and the function of the initial approximation product should be greater than 0. If it is greater than 0, for the next approximation we have to consider the a and xn instead of a and b. And if it is f of b and the f of xn is giving a product negative and which is less than 0, then we have to consider the next approximations interval must be b and xn. So in that case we have to write xn and b, because if a is 0, a is 1 and b is 2, its midpoint will be 1.5. So if you are considering a and xn, it will be 1 and 1.5. And if you are considering b, then it will be 1.5 and 2. That's why xn is written in first in the second point. And if the f of a into f of n is equal to 0, then we can stop that the f of x is equal to 0, and it gives the proper approximate root for the given polynomial. And this repetition will be according to the number of iterations until we get an approximate root. Okay. So best way to understand a bisection method is that we have to calculate a sum by using a proper polynomial sum or any transcendental. Transcendental functions are the functions which is having exponents, logarithms, as well as trigonometric functions. Okay, so here we have got a question which is using bisection method, find an approximate roots of x cube minus 9x minus 1 equal to 0 in the interval of 3 and 4. Perform up to 3 iterations only. That means that we have to do 3 iterations for this sum, and we can finalize the value for this polynomial. And also we have got the interval. The question itself is mentioned what interval it must be. So we can consider 3 and 4 as an interval, or the initial value as a and b. Here in this case we can say that 3 is the a and b is 4. So when we start the equation, it's already mentioned that the given function we have to consider as f of x. So f of x will be equal to x cube minus 9x minus 1 is what we have to write. Understand? Then a is equal to 0 and b is equal to a is equal to 3 and b is equal to 4, which we have got already from the question where the initial approximation intervals were already given. Then we have to find the function a, that is f of a, where f of a is equal to f of 3. That means in the function f of x equation x cube minus 9x minus 1, we have to substitute the value 3 in it. Then we are getting the result as minus 1. So we have to check another value, f of b, that is f of 4. F of 4 is equal to 4 cube minus 9 into 4 minus 1. The result of that is 27. So here we can see that in the case of f of 3, which is less than 0, and f of 4 is greater than 0. So both the condition are satisfying the statement or the procedure of the bisection method. That means the product of f of 3 and f of 4 is less than 0. That will be equal to minus 27, and it is less than 0. So therefore we can say consider the f of x has a root which lies between 3 and 4. So here we can see the graph also. I have written the 3 and 4 as the x values, and whatever written in the red color is the function result. So we always have to choose a result which is less than 0 and another is greater than 0. So now we are considering the 3 and 4 as the initial roots, intervals for this particular functions bisection method. Now we have to calculate for the initial approximation, that is to find the xn. So xn means it is initial approximation, so the xn can be considered as x0. x0 is equal to 3 plus 4 upon 2, because a is equal to 3 and b is equal to 4. Therefore the equation for xn was a plus b upon 2. So we are substituting it here, 3 plus 4 upon 2. That is equal to 3.5. So here we also have to substitute this 3.5 equation into our function, which was x cube minus 9x minus 1. So substituting, we are getting f of 3.5 is equal to 10.375. It is also greater than 0. So now what we have to do is we have to replace the positive side value into 3.5. Here initially what we had got was f of 4 was equal to 27, which was a positive value. Now that positive value of f of 4 has to be updated into f of 3.5, where it has becoming more less value than the positive value 27 to 10, because 10 is greater than 27. So we can also say that f of 3 into f of 3.5 is less than equal to 0, because f of 3 is negative and f of 3.5 is positive. So the product is always a negative value which is less than 0. We can say that the f of x is equal to 0, which has a root which lies between 3 and 3.5, and also you can realize this graph these values exchange from this graph. You can see that 4 is equal to f of 4 is equal to 27. Now the f of 3.5 is equal to 10. So what we have updated is the right hand side value. From the value 4 to 3.5, we changed the interval and the right hand side value, and the right hand side value was a positive side and left hand side value is a negative side. Here the positive value, since it is updated, then we have changed the f of function value from the 4 to the 3. Okay. Next, we have to start the first iteration with this given values 3 and 3.5. Here we have to substitute again. X1 we have to find. X1 will be the midpoint of 3 and 3.5. 3 and 3.5 upon 2 will give you the midpoint, that is equal to 3.25. We now this 3.25 value have to be substituted into the function x cube minus 9x minus 1. So we are getting the result as 4.0781. So this is again a positive value. So what happens? The graph value will be changing again on the right side itself. So because it is positive, which is greater than 0. So again we can say that f of 3 into f of 3.25 is equal to a negative value. That is f of 3 into, or the product of f of 3 and f of 3.5 is less than 0. So we can also say that the f of x has a root lies between 3 and 3.25. So here we can see the graph of that. Here you can see that initially we have considered from the 4 to 3.5, because 3.5 also given a positive result of the function. For the function, and again we are changing into 3.25 because 3.25 also given a positive result, because we have to multiply the products of f of x and that should be less than 0. So here we can see that 3.5 value has been again updated into 3.25. So now we have to continue for the next iteration, that is the second iteration. Second iteration again we have to find the midpoint of 3 and 3.25. 3 and 3.25 have a midpoint of 3.125. Now we have to substitute it into the function x cube minus 9x minus 1. Then we are getting an again positive value, which is 1.3925. So 1.3925 is a positive value. So we have to multiply that with a negative function result. Then only we will get a value which is less than 0. So again we have to choose the left side value, which is never changed in all these kind of iterations. That is f of 3 into f of 3.125. That is less than 0. Okay. So therefore after this iteration, the final we can put the statement, that is f of x is again lies, the root of f of x again lies in between the values of 3 and 3.125. Okay, so now you can go for the graph, which is showing again the change in the right hand side value, because the function result is again getting as a positive value. Suppose if that value of 3.125's function result was a negative one, then the value from the left hand side would have been changed into 3.25. Then the intervals might have become 3.125 and 3.25. But now in this case, while calculating the value into the function, we are again getting as a positive result. So the intervals still remain in the 3 and 3.25 is varying. So now we can go to the next iteration, that is third iteration. Third iteration, what we have to do to find the midpoint of 3 and 3.125, that is 3.0625. So in the third iteration, we need not to find the entire calculation, but we have to find this values function. So that is f of 3.0625, that is again a value positive, that is 0.1604. So it is actually, which is approximately equal to 0, because 0.16 according to the significance it is 0.1, and we can also approximately we can fix it into a 0 value. So therefore we can say that the function result of 3.0625 is approximately equal to 0 after the third iteration. Then we can fix that the f of x has a root approximately 3.0625. Then this much is what about the bisection method, but presently we can say what we have seen is an example, just example, but sometimes the value of f of 3 and f of 4 will keep on getting as a function's result in positive as well as negative. Variation also can happen. So that time which value, positive side of the function's result or the negative side of the function result is keep on updating. So accordingly we have to choose the intervals for the upcoming or the next iterations. So as well, then we should not forget a condition that the result of the f of a and f of b should be equal to 0 or greater than 0. It should be the product of f of a and f of b should be always less than 0, which is a negative value. So f of a and f of b product is a negative result. That is what we always have to remember and always have to check with all the iterations when we have to choose a new root for the function after every iterations. This much is about the bisection method. Hope you all understand that. Thank you.